All right.
Sorry about that. The rain got really bad. Had to stop. Okay. This is number 6. List all possible rational zeros, then find zeros of f of x equals 2x to the third minus 3x squared minus 11x plus 6. So all the possible p's and q's. P are all the factors of the constant terms, and Q's are the factors of the leading coefficient. So P is a factor of the constant term, which is 6. So all the factors of 6 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Okay? Q, all the leading coefficient is plus or minus 1, plus or minus 2, which leads us to P, Q, we have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 3 over 2, and that's all of them. Okay. Then we have number 7, which is solve 2x to the third minus x squared minus 9x minus 4 equals 0, given that negative 1/2 is a 0 of this. Okay? So on that one, I had already figured out that negative 1/2 was a 0 because it says it there. So if you take negative 1/2 and synthetic divide your polynomial here, you have 2, negative 1, negative 9, negative 4. Alright, we'll bring the 2 down. Negative 1/2 times 2 is negative 1. Negative 1 plus 1, negative 1 is a negative 2. Negative 1/2 times negative 2 is, negative, that's a positive 1, that's correct. Negative 9 plus 1 equals negative 8. And negative 1/2 times negative 8 is a positive 4. Negative 4 plus positive 4 equals 0. So then we take this and put it into the quadratic formula. So we have x equals 2 plus or minus 4 minus 4 times 2 times negative 8. And that's all over 2 times 2. And bring that down. Figure out simplify some of this. We're going to have 4 plus 64 over 4 which 2 plus. Okay, so when you add this together, you have 68, and to break that down, you can say 2 times 2 times 17. So you bring, you got your pair of 2's there that you can bring out up front. So you bring your 2 up, square root of 17 over 4, and to further reduce, 1 plus square root of 17 over 2. So, your answer, -1/2 is a 0, and 1 plus square root of 17 over 2, and 1 minus the square root of 17 over 2 are all zeros. Okay, number 8. We need a erase. Okay, number 8, find a polynomial satisfying the given conditions. We have a degree of 4, zeros are -2, 5, 3i, and f of 2 equals 6. So we're going to start off with f of x equals a. Our zeros, so we have x plus 2, x minus 5, and then we have x minus 3i, and then x plus 3i. And then simplify, we have a x squared minus 3x minus 10, that's these two. And then we have x squared minus 3ix plus 3ix minus 9i squared. And then to simplify, these cross out. This I squared becomes -1. So we simplify a. We're going to leave that first one alone. Yep. X squared minus 3x minus 10. We're going to simplify here. We have x squared. We don't have anything left over. -9 times -1 is a +9. At this point, we're going to FOIL basically. X4 plus 9x squared minus 3x to the third minus 27x minus 10x squared minus 90. Okay, so work some of this out. X4 is going to stay the same. We have an x squared here. So that basically becomes x squared. Let's put our -3x in. 3x to the third. And that becomes minus x squared because this here. And then minus 27x minus 90. There. Okay. Now that we have this, we know that f of 2 equals 6. So we pump in our 2 here. Simplified. We have 16 minus 24 minus 4 minus 54 minus 90, which equals negative 156A. We have 6 over here. Divide by negative 156, divide by negative 156 equals A. You really can't do anything with this other than reduce. So 6 goes into 6 one time, and 1 goes in, 6 goes into 156 26 times. And we're left over with A. So our answer, f of x equals 146 x to the 4th minus 3x to the 3rd minus x squared minus 27x minus 90. This is my answer because I had to fit a certain amount of conditions, and we were at degree 4. So when I hit degree 4 here, this is where f of x is this. So we have that, and then we have 9. Number 9 is using Descartes' rule of sines. So we were given f of x equals 5x to the 3rd minus 3x squared plus 3x minus 1. Okay, and using Descartes' rule of sines, the signs change from 1, 2, 3 times. Signs change 3 times. So let's make up a table over here. Positive, negative, and imaginary. And we know, I kind of always put a total over here just to help me. So I know I have 3 changes. And I knew that there were 3 positive changes. And the way to figure out if there's any negatives, what I did was f of negative x, and I pumped that in, so 5 negative x to the 3rd minus 3 negative x squared plus 3 negative x minus 1. So this come out to negative 5x3 negative 3x squared minus 3x minus 1. No sign changes. No sign changes. So I knew there was no negatives. And I know there's a total of 3, so there's no imaginaries in this one here. Now I also know there's a total of 3 here. And if you take 2 away from this, it becomes 1. And knowing that I have a total of 3, and I know there's no negatives, and I still have a total of 3, so that means I have to have at least 2 imaginaries in this polynomial. So we have 2 options, and we have 3 which are positive, and 1 and 2 that are negative. Or imaginary, I'm sorry, imaginary. That leads me to number 10, part B. Let me erase. Number 10, part B, I guess I totally missed it, but we were given a triangle, a right triangle. This is 50 degrees, and this was 12. So we needed to find the missing parts. And then 90 plus 15 is 140, so I need another 40 degrees to complete that. I know that length C is 12, and I kind of did it the way we learned not too long ago in class, which I just took, I needed a side, and I know that I had a matching pair, so I just started with A. So I took 12 over sine of 90, which I knew equaled the side over sine 50. And to get rid of this, I times both sides by sine 50. And this crosses out. That leaves me with A. And, well, approximately 9.20. And then I took I did the same thing. 12 over sine 90 degrees equals B over sine 40 degrees times both sides by sine 40. Sine 40. And that equals B. And that came up to be approximately 7.70. So 7.70. And that's how I found my missing parts for that triangle. Number 11 was correct. And number 12, which is my last one, we were asked cosine of 1440. So this is part A. I rewrote it as 1 over cosine of 1440, which is the same as cosine 360 times 4, which is 1 over cosine of 360 degrees, which equals 1 over 1. Cosine of 360 or 0 is 1, which equals 1. Part B, we were asked cosine of negative 240 degrees. I kind of thought about it as a circle, and here's 0, and if we go back negative 240, we end up somewhere here, which is the 120 degree mark. And the cosine in this quadrant is a negative, so it's negative 1/2. And C, which we were asked the tangent of 480 degrees, which I just took away 360 degrees. It came up with tangent 120 degrees, which that equals 3 over 2 negative 1/2, because that's the cosine of 120 degrees. And this is the sine of 120, so the tangent of 120 is the sine over cosine. So we can simplify, which what we're going to do, instead of dividing, we're going to take this and times it by the reciprocal to get our answer. So we're going to take square root of 3 over 2 times 2 over 1 negative equals square root of 3 over 1, which is negative 3. So negative, the square root of 3 is the tangent of 120 degrees. Thank you. Oh, I also wanted to say, one of the things we're learning right now was angles and distances, and I just thought it would be proper to say that when you're finding distances and angles, let's just say that's supposed to be 45 degrees. Well, if you found those 2 points, and let's just say it was a minute over. If it was a minute over, your distance in here, this point or this point, let's just say this was 100 foot on both of these. At 100 foot, 1 minute in your angle would equal 3/100ths shift either way for that point or this point, depending on which way it was. But I should probably erase that because it wasn't right to do it at this point. But thank you.